All right, everybody. So a few people asked about, and I noticed also that we need practice with partial fraction decomposition, and it's a really scary sounding thing, but it's a nice idea that I want you to think about. I'm going to do it before I even show you how it works. Like in an integration example, I'll just do it with numbers. So, for example, it's always possible to take a fraction like 2/15 and break it up into a certain number of thirds plus a certain number of fifths. And the way that this works is you can multiply both sides by 15, and then that leads you to an equation that you're trying to solve where you have um, 5 times a, because the 3 and the 15 divide to make 5, plus 3 times b. Now, in these cases here, there's actually an infinite number of solutions, and you can really choose sort of whatever you want to use. So for example, if I said let's make a equal 1, then I have 2 equals 5 plus 3b, so that would mean b has to equal -1, and it turns out to be true that 2 over 15 is equal to 1/3 uh, plus -1/5. Or if you want, you can write it as minus. And so this is something that you can verify that is true for yourself. And you also could practice, just write down a random fraction. There was nothing special about 2/15. The only thing was that I didn't choose a prime number as the denominator. So any composite number works, and you should be able to decompose it into its two partial fractions. So that's the idea here. Um, what we're really doing is using this idea that it works with numerical fractions to solve integrals that don't look solvable at the beginning. So if I have 1 over x squared plus 7x plus 12, sorry, my screenwriting is being annoying, so I apologize about that. So x squared plus 7x plus 12, don't do a natural log here because the denominator is not linear. You can only do natural log as the integral of 1 over x, or 1 over ax plus b. So what you do is you break this up into two different factors, x plus 3 times x plus 4, and you find the partial fractions that are equivalent to that. So usually the way that it's done is you say the original problem, oof, that is not coming out very nicely, x plus 3, x plus 4 equals a over x plus 3 plus b over x plus 4. And then you cross multiply, just like I did with the numerical example. So now I have 1 equals x plus 4 times a plus x plus 3 times b. Okay, and so what we're doing here is we're just choosing whatever x values we want to make this true. It turns out that there are easy x values to use that would make each of the fractions disappear. So if you plug in x equals -4, that's going to make the first factor 0. So if I make x equal -4, I usually write it over here on the side, just to be clear about what I'm doing. If I make x equal -4, I have 1 equals 0 times a plus -1 times b. So b is equal to -1. And you're allowed to do this because you want to come up with an expression that's true for all x values. Similarly, if I make x equal -3, again, sorry about the screenwriting software, my handwriting is even worse than normal. So I have 1 equals 1 times a plus 0 times b. And so I know that a is equal to 1. So now my original integral after that work can be written as 1 over x plus 3 plus negative 1 over x plus 4. Now each of them are linear terms with a coefficient of 1, so now I can integrate natural log of absolute value x plus 3 minus natural log of absolute value x plus 4 plus c. I will mention that after you do partial fractions, you're going to get the sum or difference of natural logs, and so then usually you want to simplify that. Subtraction between natural logs becomes division within natural logs like this. Oh, come on. Okay, so we'll do that, and then that's the idea of partial fractions. So if you know how to factor, then you can do the first step. You just cross multiply to set up a equation like this, and then think about after you factored, you would usually find what the x-intercepts are. It's the same idea here. You just happen to plug those x-intercepts in to make each of the factors equal 0, and then it's easy to solve for the a and the b. So please comment. Let me know if there's anything else that's tricky that comes up. Just make sure that if you end up with a factor like 1 over 2x plus 3, that you think about how that 2 affects the integral.